Okay guys, so now we're on 10.1 and this is called conics. Congratulations, 10.1 is almost done. All you guys have to do is use your textbooks to define those vocabulary. Now, even though you guys are defining parabola, I thought this is a hyperbolus. But so these are the conics that we are going to study this year. We are not going to study hyperbolas, okay? We just don't have time for that this year. Now, in 10.2, I would also like you to use your textbook and find the definition of those as well. We'll start lecturing this part right here. Equations of parabola. The vertex at h, k, and axis of symmetry parallel to a coordinate axis when a is bigger than 0. So that means when a is positive, okay? So all of your vertex, all of these forms right here, we will always use h, k as a vertex. Okay, now you will have a focus. The focus is going to be h plus a, k. You will have a directrix, x equals h minus a. And remember, it will make more sense if you guys do the vocabulary and the example above, okay? Your equation for the parabola is going to be y minus k quantity square equals 4 times a times the quantity x minus h. Now, because it's y square, it's going to, this is called axis of symmetry. AOS is axis of symmetry, is parallel to the x-axis, and it opens to the right. Oops. Okay. Next one, we will have the equation of y minus k quantity square, and we will have negative 4a, and we have x minus h here. Now this, because it's negative, it opens to the left. Opens to the left, okay? And the axis of symmetry, it's still going to be parallel to the x-axis. Now, we are going to have the focus as at h minus a, k, and the directrix will be x equals h plus a. Next one, we will have something that opens up, which you guys already know how to graph. Opens up, meaning that the x will be square. So x minus h quantity square equals 4 times a, so that's positive. That's why it opens up, times the quantity of y minus k. Now the axis of symmetry, it's parallel to the y-axis. Okay, and again, make sure you guys define the vocabulary above on the prior page before copying this down. And try example number 1. Now your focus will be h, k plus a. And the directrix will be y equals k minus a. You will also have a parabola that can open downward. Okay, now the axis of symmetry is still going to be parallel to the y-axis. The equation is slightly different. It's just going to be a minus instead of a plus. So this is minus 4a times the quantity of y minus k. Now your focus is still h, but it's going to be k minus a. And the directrix will be y equals k plus a. Find an equation of the parabola with the given information. Find 2 points that define the latus rectum. Graph the equation by hand and label the directrix, axis of symmetry, and lattice rectum. So they give you a vertex at 4, -2. So let's go make some tick marks over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, I'm gonna get a different color pen since I already used that black one for tick marks. Okay, let's plot the vertex first. Vertex is 4, -2. So 1, 2, 3, 4, -2. So here's the vertex. Okay, and they gave us a focus. So let's label it V. And they gave us a focus at 6, -2. So focus is 6, -2. Okay, and remember, if you guys already copied down the definition of all of these vocabulary up here, then you should know the focus is always inside of the graph, meaning that because a focus is on the right side of the vertex, we know this opens to the right. Okay, so we know it opens to the right due to the fact that the focus is on the right side. Okay. Now, the focus and the directrix, it's exactly the same distance from the vertex. So what I mean is that this is a unit of 2. So that means the directrix is right behind it, 2 units behind the vertex. So if we count backwards 2 units, this is the directrix, okay? And we want to label it. And yes, directrix is a line, and we will label this line as x equals to 2. Okay, remember it says label directrix, axis of symmetry, and lattice rectum. Now, the axis of symmetry is right in the middle of your parabola. So that means it runs through the vertex and the focus. Okay, so this is your axis of symmetry. And this line is y equals -2. We have to label everything. Okay, so check that, check that. So what are we going to do here? How are we going to write this equation? Okay, now you guys know that this opens to the right. So if we look back here, if it opens to the right, we are going to use this equation right here. Okay, let's copy that down. And guys, when you guys are taking notes and doing your homework, just copy the formula or the equations down. So that way, by the time that you guys are taking your test, it's already in your memory, in your brain, okay? Okay, let's fill in the h and the k. Your h is going to be 4, your k is going to be -2. So y negative and a -2 is now down to y plus 2. That's the k equals 4 times a. And then h is going to be -4. So right now, that's all we have. Okay, so now we have to find that a value. Remember we were talking about the distance between the vertex and the focus? That distance is actually an a distance. Okay, so that distance right there is an a distance. So from the directrix to the focus is 2 times a distance. Okay, so we know a equals 2. So what do we have? We got y plus 2 quantity square equals 4 times 2 times x minus 4. So we are ready to finalize our equation, and that's 8 times x minus 4. Let's box that up. Now, what is 8? 8 represents the total length of the lattice rectum, okay? So lattice rectum length, it's 8 units. And what does that do? Let me tell you what that would do for us. 8 units is the total distance for the graph, okay? So that means half of it from the focus. So remember, this is from the focus. Lattice rectum, it's going to be perpendicular to the axis of symmetry. So because I have the lattice rectum length is 8 units, I'm gonna go up from the focus 4 units, just like that, and down from the focus 4 units. And that will allow me, make sure I'm counting 12. 1, 2, 3, yep, that's 4. 4 and up, 1, 2, 3, 4, oh. I'm short. 1, 2, no, 1, 2, 3, 4. No, the first one's right. My bad. Okay, so now it allows me to have 2 more points to graph the parabola, just like that. So we are graphing the parabola simply using the vertex and the 2 points of the lattice rectum. Okay, so lattice rectum points, because it says here, find 2 points that define the lattice rectum, and we have them both. So the 2 points, L, R points, okay? 2 points are from the focus. We know the focus started at 6, so both of them were still going to have 6 for the x-axis. We know the total length of the lattice rectum is 4, so we take the y value of the focus and we add 4 and we subtract 4. So if we add 4, we have 2, and if we subtract 4, we are going to have -6. So those are the 2 points that will define the lattice rectum. We already have the axis of symmetry label, but let's write it right here. Axis of symmetry, y equals -2. And we have the directrix. It's already on the graph, but let's just label it right here so we can have it all in one spot. Okay, so hopefully you guys got the same exact thing that I have here. Okay, so now hopefully that connects and it makes sense with the chart. Let's try B, okay? On B, I'm giving you guys the focus, which is -1, 2, and the directrix at x equals 3. So the first thing you always want to do is to do a little sketch of that. Why do I need that? Okay, so let's make some tick marks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. Let's plot. Ready? Focus is -1 and then up 2. I'm going to use F for focus so I know what it is. Then the directrix is x equals 3. 1, 2, 3. So here is the directrix. Remember, the directrix and the focus, directrix. Okay. So in the middle of the focus and the directrix should be your vertex. Okay, so let's find the distance right in the middle. So this right here is right in the middle, which is your vertex, which we have, that is 1, 2. Let's write that down. Vertex is 1, 2. Now we know since the focus is on the left-hand side of the vertex, we know it opens to the left. Okay, then if it opens to the left, let's go and see if we can write down the formula. The formula is going to be y minus quantity, y minus k squared equals -4 times a times x minus h. Now let's find what a is. Remember, a is the distance between the focus and the vertex, or the vertex and the directrix, okay? And it looks like it's 2 units. So this here is 2 units. So a equals 2. So with that, we can quickly write an equation. Y minus k is 2. So that's going to be -2 squared equals -4 times 2. I'm just going to write straight up 8, okay? Times x minus 1. Let's box it up. That is our final equation. Now we will define the lattice rectum length, LR. The length is going to be 8 units, okay? 8 units. And how do I know it's 8 units? It's always this right here, okay? The lattice rectum is always the absolute value of 4 times A. So this is going to be your lattice rectum. Now, because I do know it's 8 units, let's go and finish graphing it. That means I'm going to go up 4 units from the focus. 1, 2, 3, and 4. I'm going to go a little bit above there. 1, 2, 3, and 4. With the dots, I can now sketch out my graph just like that. If you miss your dot there, just make it fatter. Now we will also find the directrix, or label the, axis of symmetry. Okay, AOS, which is now y equals 2. Y equals 2. Okay, let's write in here. AOS, y equals 2. Box that up. What else are we missing? The 2 points of the lattice rectum. And we can simply just look at the graph, or we know the 2 points for lattice rectum. We know the focus has an x-axis at -1. So we both know both of those are going to be -1. Now the lattice rectum length is 8. So that means we're going to add 4 and subtract 4 from the focus y coordinate. So if I add 4, that's 6. If I minus 4, that's negative 2. And then box that up. Bam, just like that. Let's try one more right here. Okay. So for this one, it says the vertex is at 0, 0. So let me make some tick marks. I'm going to get it black to make tick marks. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so let's plot the vertex right away. 0, 0. Let's label it V. And they gave us the axis of symmetry of the x-axis. Okay, so that's right on the x-axis. Okay. Oh, where did that go? There you go. So right here is AOS. AOS. Okay, what else did it give us? And it contains a point 2, 3. So when you see the contains a point, that means 2, 3 is going to be on the graph. So let's plot that point. 2 up 3. So it's on that curve. Okay. We don't know where the focus is. We don't know how far the lattice rectum is. So let's go and figure this out. We know if the vertex is at the origin and there's a point on the right side, we at least know it opens to the right. Okay. Then we know at least if it opens right, the focus, okay, it's a unit from the vertex. So that means whatever h is, we could add a, and k should be the same. Well, what else do we know? We also know the directrix is behind it, right? So directrix is going to be x equals h minus a. We need to figure out this a value really bad, don't we? All right, so let's write down the equation. We know it opens right, so let's just write down the formula first. So it's in our brain, okay, just like that. Well, h and k's are both 0. So that means this is y squared, 4 times a, and then just times x. Well, let's find a. They gave us a point, 2, 3. So let's plug that in. 3 is y, so that's 3 squared equals 4 times a, and 2 is x, so this is 9 equals 8a. Divide both sides by 8, so a equals 9 over 8. Okay, not a friendly number, but that doesn't mean it's not a number, so let's go and fill in our focus. So focus will be now h plus a. H is 0, so that's going to be 9/8, 0. Let's go plot that. Okay, 9/8 is just slightly over 1. Bam, just like that, focus. Okay, then the directrix is just simply h minus a. Well, h is again 0 because the vertex is at the origin, so this is negative 9/8. All right, box that up. So I'm going to go behind and just a tad bit to the left of negative 1. I'm going to write directrix. And I'm going to write x equals negative 9/8. All right. What I'm missing is actually my total length of the lattice rectum. Okay. Total length is absolute value of 4a. 4a. And we see that a is 9 over 8. So that's going to be 4 times 9 over 8. That will give us a total distance. Let's reduce, so 9/2 units. So that means it's 4.5 units, okay? That means I'm going to go up from the focus half of 9/2. So that's 9.25. Okay, so 9.25 is what I'm going to go up by. So that's going to be, so 9.25, okay? So that's 2.25. So let's go up 2.25 from the focus and go down 2.25 from the focus and connect dots. Now, if they already gave you 1 extra point, technically, can you graph using that, reflect on the other side? using that one extra point that they had, of course, but that's not the length of the latus rectum, so make sure you're super mindful, okay? They do want us to get 2 latus rectum points, so we are going to use the focus. The x will be the same as the focus x, so both of them will have 9/8. Now all we have to do is add 2 1/4 from the y coordinate of the focus and subtract 2 1/4 from the y coordinate of the vertex. Well, I'm sorry, from the focus. Okay, add and subtract 2 1/4 from the focus. So while the focus is at 0, right, the y coordinate, so what that's going to happen is -2 1/4 and a +2 1/4. So those are our 2 points for the latus rectum. Okay, so make sure we have our equation box up, which we don't. Let's go and take this down here. Y squared equals 4 times a was 9/8 x, and so that's y squared equals 9/2x, and box that up just like that. Okay. For 10.2, find the vertex, the focus, the directrix of each parabola and graph it by hand. So it's going to be, I want to make sure that I am writing down all of the things they are looking for. So first, it wants us to find the vertex, find the focus, find the directrix, big D, and of each parabola, and then graph it by hand. All right, so these are all of the things that we are supposed to answer. So 2a, quantity, y plus 2 squared equals -4 times x minus 3. Because your y variable is being square, so we know that it will either open to the right or the left. And this is negative, so we know for sure that it opens to the left. Okay. We have a few things we can find right away. First thing is we are going to find the vertex. The vertex is going to be your h comma k. So h is going to be 3 and your k is going to be -2. Next, we need to find an a value so that way we can locate the focus and the directrix. So a, it's going to be 4a, or -4a equals to -4. Or you can think of it as an absolute value of those. Since it's an absolute value, it comes out to be 4a equals to 4. A comes out to be a 1 unit. If it's 1 unit, we know that from the vertex to the focus is 1 unit, and from the vertex to the directrix is also 1 unit apart. So best thing for us to do right now is plot it out. Let me make some grids. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. Vertex is at 3, up 3, -2. So 3 down 2, label it V. We know that it opened to the left, so the focus is going to be over here. I can find that location right away. That's 2, -2. The directrix is 1 unit, aka a unit. So here's directrix. X equals to 4. X equals to 4. Okay. If we know those 3, we now need to find the total length of your latus rectum. Length of, and it's always an absolute value for A. Absolute value for A happened to be an absolute value of 4, which is 4 units total. Okay, if I know it's 4 units total, I can go up 2 from the focus and down 2 from the focus to finish graphing by hand. And remember, I may ask you to find the location of the latus rectum, so might as well get used to labeling these. This is 2, 0, and then this is going to be 2, 1, 2, 3, 4, -4. Okay, so those are them. We graphed it by hand, checked. We found the vertex, the focus, and the directrix of each parabola. Example 2b, very similar, except that we need to complete the square. Ready? To complete the square, we first will factor out the 2. We know the y variable is being square, so we know it either open to the left or to the right. So y squared plus something, oh, I'm sorry, not plus something yet, plus 6y plus something blank equals negative x plus 1. We do not need to complete the square for the x because we don't need to factor that out. Half of 6 is 3, 3 squared is 9. I'm going to add 9 over here, but that 9 is really being multiplied by 2, so this is really 9 times 2. This is now then factor out as a y plus 3 quantity square equals a negative x. 1 plus 18 is really now 19 plus 19. And then we're going to get rid of this 2 in the front very soon. But before I do that, I want to factor out a negative 1. So that means I have x minus 19. To get rid of this 2 in the front, I'm going to multiply that by a half. What I do to that side, I do to this side. Here is our equation. Y plus 3 quantity square equals negative 1/2 times x minus 19. This is our equation. Okay. Now I need to answer the parts that they want. Vertex, focus, and directrix. Here we go. Vertex, focus, and directrix. Vertex is always h comma k. So here's h and here's k. So that's going to be 19 comma negative 3. Ooh. Okay, well, I'm definitely not going to do 19 take marks. So for the x location, I will just do every 5 units. 5, 10, 15, extend this all the way out, 20, and 25. And the y-axis, I can stick it 1, 2, 3, 4, 5, 6, 7. Okay. So vertex is negative 19 comma 3. So it's right here. Eyeball 19. Sometime 19 comma negative 3. So here is your v. Next, I need to find an a value for us to even find the focus and the directrix. Are you ready? A value. Well, we know that it opens to the left because of the negative 1/2. See this right here? We are going to take negative 1/2. We're going to set it equals to negative 4a. To get rid of negative 4, we will multiply this by negative 1/4. Negative 1/4. So a will come out to be, ooh, super tiny, isn't it? A is 1/8. Oh my. So that means we are going to eyeball 1/8. So the focus, we know it opens left. So the focus is somewhere here on this left side and is going to be super close to the vertex. This is just 1/8. So what does that mean? I'm going to take the x coordinate of the vertex and minus 1/8. So the x coordinate of the vertex was 19. So 19 minus 1/8 comma negative 3 is the new order pair of the focus. Take away 1/8 is 18 and 7/8 comma negative 3. This is your focus. That gets filled in right here. 18 and 7/8 comma negative 3. And we're going to do the same thing to the directrix. The directrix is 1/8 behind the vertex. So that means it's going to be an x equals 19 plus 1/8, which is really 19 and 1/8. I'm going to try my best to graph out our directrix. I'm not going to hold you for this particular approximation. Okay, there you go. So that's going to be x equals 19 and 1/8. I need now to know find the length of the latus rectum, so I know how far up to go. Length of lattice rectum, which is an absolute value of 4a, which we already know an absolute value of half. Well, the total length is a half. That means you're going to go up a quarter and down a quarter. I'm going to see if I can fit a quarter in here. A quarter from, remember, you're going a quarter from the focus. So here's a half, here's a quarter. I'm just going to eyeball this. This is going to be one skinny, okay, one skinny according to my grid. I went up a quarter and I went down a quarter from the focus as best as I can make a quarter. Then if I ask you to find the order pairs of the lattice rectum, we can take the y value of the focus and we add a quarter, and we can also take the y value and we subtract a quarter. And remember, the reason we do a quarter is because it's half of the total length. So if I ask you to find the lattice rectum point on the top here, then we're going to take, remember, the y value of the focus. So the x value should be exactly the same. The y value is -3, and we're going to add a quarter. Of course, we simplify. So 18 and 7/8, comma, -2 and 3/4 is the top piece of that. We could also do the same thing on the bottom. I'm using color. It's going to be x coordinate is the same, 18 and 7/8. And we're going to take the -3, which is the y coordinate of the focus, and we subtract a quarter. So this final answer for this bottom order pair for the lattice rectum is 18 and 7/8, comma, -3 and a quarter. So if I ask you for the order pairs, those are the two order pairs if it's ever asked, and that's how we find them. Example 3 of 10.2, write an equation for the parabola. First, if you look at this parabola, we know it opens up, so right away I would write the equation out, so by the time you are asked to take an exam, it's already in your memory, okay? And let's identify the vertex. Let's see, this vertex is 1, comma, -4, so I can fill that in right away. Your h is 1, your k is -4. So x minus 1 squared equals 4 times a y minus and -4. Two negatives will make it now a positive. Well, if I can find a, then I would be good. Well, to find a, you can pick any point that's nicely, well, not all the time that I'm going to give you the dots, but if it's any point that you have not used, since I've already used the vertex, I can't use again. But my favorite point is when one of it is 0, so I would use 3, comma, 0. So x is 3 minus 1 squared equals 4 times a. Y is going to be 0 plus 4. This is going to be 3 minus 1 is 2. 2 squared is 4 equals 4a times 4. That's 4 equals 16a. To get rid of 16, we are going to multiply by 1/16 or divide both sides by 16. This will give us a 4/16, which is a quarter. So your a is a quarter. Then all we have to do is plug it back in. Final answer is going to be x minus 1 quantity squared equals 4 times 1/4 times y plus 4. Yes, you must always simplify. So final answer is 1 minus x minus 1 squared equals 4 times a quarter is 1, which you technically don't need to write the 1 in the front. Yes, you may, but you don't have to. And this is as far as you need to go. And it's example 4 of section 10.2. A searchlight is shaped like a parabolic of revolution. So a paraboloid, it's just a parabolic shape, okay? So it's a parabola shape of revolution. So just fancy for in terms of parabola. If the light source is located 2 feet, so this is what I want you guys to know right here. Light source is located 2 feet from the base along the axis of symmetry, and the opening is 5 feet across. How deep should the searchlight be? So a searchlight is in essence a flashlight. And a flashlight, I'm gonna try my best to draw it for you, okay? Here's sort of and there's a light bulb somewhere in the bottom, and we have light source. So that's a light source. Now the light source is the focus from the base. So if I make the base at we're gonna make the base at the origin because it's just the easiest location. So the base is at the origin, 0, 0, which is your vertex, okay, which is your h, k. So when the base or the vertex is at the origin, h and k will always be 0, 0. Now the word light source, this is where the focus is. They gave it to us. The focus is right now at 0, 2. The reason I know 0, 2 is because this is a parabola opening upward. And then they even went further and said, okay, well, the opening is 5 feet across. So this is 5 feet across. What that means is, and I know this order pair. This order pair is 2.5 feet, some y value. And this order pair is negative 2.5 feet, some y value. And again, when you can, always try to put the vertex at the origin. So now what is it looking for? It says, how deep should the searchlight be? How deep means I'm looking for the height of this searchlight. I'm looking for the height means I'm looking for the y value. Since it opens up and the vertex, so let's put it back into the formula of a parabola. Opens up meaning that your formula is x minus h quantity square equals to 4a times y minus k. Well, h and k are both 0 because the vertex is at 0, so x squared equals 4a times y since k is also 0. If I can find y, then that would be my answer. Well, I do know x. X is, according to this, x is 2.5 when y is unknown. I can definitely plug that in. So 2.5 is really 5 over 2 quantity squared equals 4. Well, I have one equation and 3 variables. I know what x is. I can plug that in. A, so let's remember, A is the distance from vertex to focus, okay, or vertex to the directrix. So remember that. Since we have the focus, A happened to be 2 feet. So plug that in and we're solving for y. So 5 over 2 squared, that's going to give me 25 over 4 equals 8y. To get rid of 8, we will multiply both sides by 1/8. 1 over 8. And y now comes out to be 25 over 32 feet. So how the deep, okay, the searchlight is is 25 over 32 feet deep. When you can, I do prefer the simplest exact answer. Start the definition for the ellipse, okay? 10.3. All right, the first definition is the ellipse. An ellipse is the collection of points in the plane whose distance from two fixed points these two fixed points are also known as the foci, add up to a constant number. Okay. Now the foci are two fixed points on the interior of the ellipse. Okay, so you guys remember the parabola had one focus. Okay, now the ellipse has two foci, which is two of them. So what does that mean by these two definitions? Let me just give you a little picture, in which we will probably draw a lot more pictures in a little bit. So let's call this foci 1 and foci 2, okay? And it's made up of, and it says here, a collection of points. I mean, every single exterior here, these are all points that's made up that's collected to make an ellipse. Okay, then it says collection of points in the plane whose distance in two fixed points. So let's say I'm going to pick that point, this distance, and that distance. Okay, if I add those two, let's call that should be the same as if I were to pick this point and add that with that. Okay, so the distances in red, if you add those two distances, should be exactly the same as the two green distances. And let's say I want to pick this point. From here to there should be the same as if we would from here to here. They should be on the same exact line, because the two foci should be on the same exact horizontal line. But because I don't want to draw it on the same one because you can't see, but this distance here from foci 1 to this dot here on the right side, add that to focus number 2 to the same dot. That should be the same exact distance as the red and as the green. And if I want to go further, we can even make, okay, well, what if we want to make this dot? With that distance plus that distance, all of those distances, when I add them up, the blue should equal the red should equal the green should equal the black. So that's what it means to be an ellipse. Okay, so that's the definition of the ellipse, with the two fixed points, which are called foci. Okay, if you take the distance from the two foci to any point on the ellipse, and you add them up, they should give you the same constant. All right, major axis. Let's move on to that. Is the line containing the foci. So that's why earlier I said the focus 1 and focus 2, the two foci, should be on the same line. So this is now called the major axis. Okay, all of that right there. Focus 1, focus 2, so two foci, same major axis. All right. Minor axis is the line through the center and it's perpendicular to the major axis. The center is the midpoint of the major axis, major axis, or minor axis. Okay, so the minor axis, if we use the same picture, is going to be goes through the center and is perpendicular to the major axis. So here's the center right there. Okay. Vertices are 2 points of intersection of the ellipse and major axis. Okay, so what do I mean by that? So the vertex are the 2 points of the ellipse, which is the outer, and where the major axis is. So those are vertex 1, vertex 2, together they're called vertices. The length of the major axis is the distance from one vertex to the other vertex. Now, normally, I would ask you to use your electronic device to define the whispering galleries, but I'm just going to give it to you in this set of notes, okay? Whispering galleries are domes that are constructed in a way so sounds produce at any certain point are clearly audible at another location. And we need to know this fact because this will be used in our application later, okay? Now the next 3 vocabulary, I'm going to draw a picture and then I'm going to define them at the same time, okay? All right, let's go draw this picture. So here is an ellipse. Pretend it's a perfect ellipse. Okay. So we have an ellipse. I'm going to get a different color. Let's say that you have a planet here orbiting around. So the planet is going to orbit around the sun. Let's make the sun right here, okay? Around the sun in an elliptical shape. And I'm going to make the sun, there you go. All right, so let's go and define this. Aphelion, when a planet is farthest from the sun. So what it means is this. If you look at this planet, okay, so currently I have it drawn in green, but as you know, it orbits around the sun in this elliptical shape, and it moves here and here and here. So when it is over here, like here, okay, then that is the furthest location from the sun. So we call this distance right here, students, from the green to the sun, aphelion. Okay. Next is perihelion, when a planet is closest to the sun. Okay, so as it's orbiting around the sun, and again, this is not drawn to scale, okay? If it's over here, then this distance right here is the closest to the sun. It's not drawn to scale, so do not hold my ellipse to that. But so when it's at the 2 vertices, it's really where we're measuring it to the sun, okay? Since I can't draw to scale since it's by hand. So this blue distance from the sun to vertex number 2 here is perihelion. So I'm going to spell it right here. All right. The mean distance of a planet from the sun. So just so you guys already know, the mean distance means the average. So the mean distance is the length of the semi-major, which is semi means half, axis of the elliptical orbit. Okay. So if we look at the major axis, okay, so here's the major axis from here all the way to here, from one vertex to the other. So the mean distance is half of that. So let's make the center. Let's pretend the center is right here in the black. So the mean distance is from here, one vertex to the center. This is the mean distance. Okay. So the mean, two of the mean distances, okay, is going to equal aphelion plus perihelion. All right. Let's go on and do the theorem. Theorem number 1 here. Equation of an ellipse. When you have the center at 0, 0, so let's draw that out. Center at 0, 0. Major axis is along the x-axis, so let's make it super y, vertex 1, vertex 2. And then that means the minor axis is going to be above here, since the major axis is on the x-axis. Let's draw this out really quickly. Now from your activity, you guys by now should know a couple of things. You guys should know, and again, not to scale here, okay? That the foci should be on the x-axis as well, since the vertices are on the x-axis. Then the distance from the center to one of the foci is going to be called letter C. So here is C. The distance from the center to the minor axis is called B. Then the distance, if we were to make this triangle, just like that, this is a right triangle. Since the major and minor axes are perpendicular, this is now called A. So let's fill out a few things. We will have the foci at plus or minus C distance from the center, and the y is still at 0. The vertices are going to be plus or minus A distance from the center, and the y-axis is still 0. We can also go and label these points here. This should have been labeled 0, comma B. This down here is 0, comma negative B. Over here, all the way over here, yes, that's also A, comma 0. So let me draw that out again in red. Remember, A is the hypotenuse of the triangle, but this distance right here, from the center to the vertex, is also A. Over here, this vertex 1 is negative A, comma 0. Okay. So let's go and write a standard form of our equation with the center at 0, 0. It's going to be y squared over a squared, since it is positioned horizontally. So the a squared is going to be the biggest value, so the x variable gets the a squared, plus y squared over b squared equals 1, where a is the biggest number out of the ABCs. So A is going to be bigger than B, and both of them will have to be positive, which is greater than 0. Now, based on a Pythagorean theorem, since A is the largest value, it's going to be B squared plus C squared equals A squared. Okay, And the major axis, it's on the x-axis. All right, that's what it says right here. All right, now let's go and do the next theorem. This one says the center is still at 0, 0, but now this time the major axis is on the y-axis. So this is more vertical. Okay, so this is 0, 0. Now I'm going to make a dot here. So let's call that vertex 1. Vertex 2, we will make the minor axis shorter. Let's draw this out. Okay, so very similar to the horizontal position earlier. Then if we know the vertices are on the y-axis, then we will have focus 1 here, focus number 2 here. Let's draw it out. Now from the center to the focus, it's always C. I don't care what you guys do, it's always C. Then center to the minor is always B, okay? So that leaves us, this last distance is going to be called A, always. No ifs, ands, or buts about it. Let's label some points. From this point is going to be B, 0. This point over here is negative B, 0. Now again, remember, from the center to the vertex is totally not drawn to scale based on this letter A. But that is going to be 0, negative A is the A distance, same A distance as this guy. Okay, just be very, very mindful. I know I'm not drawing it to scale, but that A value is the same A value from the hypotenuse of your triangle. Then up here, this vertex number 1 is going to be 0, A. Okay, let's fill out. You will have the foci going up, so that's going to be 0 plus or minus C. You have the vertices, 0 plus or minus A. Okay, the standard form is going to be, since the y square, okay, now since it's positioned vertically, the y square would get the A square, because the A value is always bigger than the B. Then that means this gets a B square, and it must always equal to 1. Where A must always be bigger than B, and both values must always be positive. And again, similarly to the previous theorem, it's going to be C squared plus B squared equals to A squared for the Pythagorean theorem. And again, this is only when it's vertical, where the major axis is on the y-axis. Okay, so what if we have an ellipse that's not at the center? Similar, except that we are going to call the center H, K. So, oops, I don't need a highlighter, so I need a pen. Okay, so both center are no longer at the origin. Let's call it H, K. We'll draw the first one with the major axis. It's parallel to the x-axis. Let's draw it out, okay? Let's make the center right here, H, K. And let's make this vertex right here. Vertex 1, vertex 2. Not to scale at all. And let's make this the minor, just like that. Okay. All right, let's draw it out. So normally when I talk about ellipses, I call this horizontal. So that means this is your major axis. So focus 1, focus 2, let's just fill that in. Okay. Now when you look at the foci, as you can see, it's moving along the horizontal, so only the x values will change. So from the center, you're going to take the H, which is the x coordinate of the center. You will either add a C value, which let me label that for you. This is C, okay, or minus C to get to focus 1. So you add plus or minus C. Now the y value does not change from the center. Now let's talk about the vertices. The vertice from the center to the focus I'm sorry, from the center, the vertex is the letter A. So here's the center, here's the vertex, the whole green piece is A. So again, you can take the H value, add A to get the vertex 2, or minus A to get the vertex 1. So we're going to take H plus or minus A, comma, K. Your standard form equation, because it is positioned horizontally, we're going to go, okay, the X variable will get the A square. Then that means, oops, I'm writing too big. Okay, this one I'm trying to squeeze in. Oh, nope, still too big. All right, let's squeeze that in to fit in the box. So X minus H quantity square will get the A square, plus Y minus K quantity square will get the B square equals 1. And again, the B square, okay, let's write it plus C square, it's always A square. That is the Pythagorean theorem that you have to use. So what's a B? B is from here to here, and A is this guy right here, since this is the right triangle. Okay, let's move on to this guy here. The H and the K is still not at the origin, call it, we're gonna still say the center. Let's make this right here, okay? H, comma, K. We will say that the major axis is going to be parallel to the Y axis. Okay, so let's go up here to say vertex 1, down here to say vertex 2. So the minor axis, let's make it short here and here. Let's draw that out. All right. So first box says the foci. The foci would be here, focus 1 and focus 2. As you can see, the H value is not changing, only the K value is changing, right? The Y value of the coordinate changing. So we will say, okay, well, H is not changing. We'll keep H as is. The K, if we add a C value, it will give us F1. If we minus C value, it will give us F2. So from here to here is C. So plus or minus C. All right, now the vertices is very similar, except we would need an A value. So again, remember, the vertex to the center is an A distance, okay? A distance. And just to remind you, the B distance is from the center to the minor. And so that means I'm going to use green. From here to here, it's A. And that's always perpendicular. So, same thing, we're going to go H, comma, K plus or minus A, and the standard form. X minus H quantity square over plus Y minus K quantity square, and it always equals to 1. Now, because it's vertical, that means the Y will get A square, and that means the X's now get B square. And again, same Pythagorean theorem, B square plus C square equals A square.